This is the help video for the student practice Volcano Feedback Loops. Now, I'm not going to give you too much help because you already understand how to identify feedback loops, but I'll show you kind of what you should focus on here. I mean, obviously you should focus on the whole thing, but I can help you. So this one, you're going to have to really read carefully. This background information is going to help you a lot. Essentially, what I did was I gave you everything you need to solve this problem. What I want you to do is to figure out if this volcanic eruption that I describe here is an example of positive feedback or negative feedback. So first, what you're going to do is read this background. When volcanoes erupt, it tells you all about what happens. I tell you about ash, what it does. I tell you what CO2 is and what it does. I tell you, well, you know about photosynthesis, but I remind you what photosynthesis is and what it does. And what you're going to have to do is these questions ask you to analyze a graph. The graphs are here. I didn't want to put these graphs on paper. I'd have to waste a bunch of paper, and also they wouldn't be in color. So make sure as you have your worksheet sitting in front of you, you're going back and analyzing the graphs that it tells you to. Now, I'm going to help you out with these graphs a little bit. This is not real data. I simplified some of this. I made this question up. So if you look online, it won't really help you. But we have on the y-axis million tons. Million tons of what? Well, it's of CO2, right? And this is showing that as time goes on, the amount of CO2 in the atmosphere, atmospheric CO2, changes. And you have to analyze this graph to figure out how it changes. Likewise with figure B. Now we have cubic kilometers. Since atmospheric ash is like a little cloud of ash, it is three-dimensional. It's not flat. We measure that in cubic kilometers. So again, we're looking at how many cubic kilometers of atmospheric ash there are over time. In figure C, we're checking out the rate of photosynthesis. Don't worry about the mu moles per second. This is just how you can record or measure the rate of photosynthesis. But when you're looking at these three graphs, remember, in the directions, it says that you're going to examine all those graphs as well as the rate of photosynthesis over time following a volcanic eruption. So imagine you're a scientist at a volcano, it's erupting, and you collect some data. Here's the data you would collect. This is all in the same area right around the volcano, either in the air or the plants right around it, near it. And this is how things are changing. Again, read very carefully. You're going to have to put some things together in this one. All right? You're going to figure some things out, analyze the graphs, and then you have to use the background information to come up with an answer. Is it a positive or negative feedback loop? And explain why.